Hello, thanks for watching this presentation. I hope you enjoy watching it as much as I enjoy talking about this topic. Before I start, let me tell you that what you're about to see has been done as part of a project that we call iterate. There's an amazing group of people who have been hard at work to make this happen. I'm willing to guess that a few people, while looking at KubeCon's program, encountered the title of this presentation in the CI/CD track, and perhaps started rolling their eyes, thinking to themselves, "Oh, this is yet another demo on how to do canary releases in Kubernetes." This is not that. I will not talk about how to integrate tools in your CI/CD pipeline to perform canary releases on Kubernetes. What I want to do is to raise awareness of a fundamental problem that is at the core of techniques such as canary releases, A/B testing, and ABN testing, but a problem that has been largely ignored in the community. So I want to offer a solution to the problem, an open solution to the problem, and engage the community in that discussion. And yes, in this process, I'm going to show you two demos. When we talk about techniques such as canary releases, A/B testing, and ABN testing, we know it's all about agility. We want to find ways to deliver code to production as quickly as we possibly can in order to survive in a software-driven market. We want to stay relevant. We want to retain the customers that we have. We want to attract new customers. But there are opposing forces that make us think twice before releasing new code into production. We are always worried about the fact that bugs might find their way into production. We might be worried that our code will not be performant enough and perhaps violate performance guarantees that we are promising to the same clients that we want to retain. In the worst case, we might worry that our code changes will inadvertently cause the revenue of our company to decline. Agility gives us the opportunity to learn, right? The more we deploy code into production, the more we learn about how the code behaves in production or in test environment. More importantly, we have an opportunity to learn about our users. What users want. We have the opportunity to learn how to find new ways to increase our company's revenue. And how about that? As we learn all those things, how about maximizing the revenue of our company? What if I told you that these things can be possible? And you're probably mapping to your mind the concepts that I'm talking about here to the same techniques that we mentioned a few moments earlier. Code behavior in production, you can think about canary releases for that, a performance test. Test what users want can be mapped to A/B testing or ABN testing. I would like to collectively call these techniques continuous experimentation. And the word continuous here is important because it has the connotation that these things are done continuously, very, very frequently. And in order, it allows us to actually embrace that mindset of always learn about our code, about our users, about new ways to thrive in the market. However, in order to embrace that mindset with peace of mind, there's an important piece that's important, and that's analytics. Now, make no mistake, continuous experimentation is an analytics problem at its core, and a comparative analytics problem. It's about comparing competing versions of the code that are running simultaneously. I observed that most of the discussion in the community around this topic tends to revolve around the low-level mechanisms that enable canary releases and ABN testing. People say, "Oh, here's a way for us to split the traffic. Hence, we can support canary releases." Or here is a way for me to limit the users that will be able to see an experimental version of my code. Hence, I can do A/B testing. But that's not enough. A comprehensive solution needs to be able to support these low-level mechanisms and at the same time have the ability to assess the versions and perform traffic control in a way that it's intelligent. So with iterate, we provide a statistically robust statistical inference techniques to perform version assessment and traffic control. Version assessment version assessment that comes with confidence in the probability that each version will be able to become the winner. And traffic control that will allow iterate to continuously assess the competing versions, explore how these versions behave, and in a way that is as safe as possible. Here's an overview of how iterate works. Imagine that you have a number of versions deployed in your Kubernetes cluster, and each of those versions have some metrics associated with them: performance metrics, correctness metrics, perhaps even business metrics. Iterate analytics is able to extract information about these metrics from these versions and analyze how these versions are behaving and identify at each point in time which is the most promising version. Along with this version assessment, iterate analytics also provide versions can be continuously analyzed in a way that is safe, in a way that allows iterate to continue making assessments going forward. Iterate controller is a Kubernetes controller that periodically get assessments from iterate analytics with a frequency that is specified by the user and applies that traffic control recommendation. And we continue in this feedback loop where metrics are flowing from the versions into the Prometheus time series database, and iterate controller gets assessments from analytics, and so on and so forth. And this proceeds until a version can be declared a winner or until the experimental duration finishes. With each version assessment, there is a confidence associated in that decision. So iterate makes a decision, makes a recommendation, and gives you how confident it is in that decision. It supports different traffic control strategies. Progressive is probably what users will want for pretty much all the use cases. And on top of the smart traffic control, users can specify some safety filters to, for instance, cut off traffic on failure, to cap the maximum amount of increment from one iteration of the experiment to the next, provide ways to limit the users that can see the experiment traffic, etc. Another component of iterate that's worth mentioning is what we call iterate trend. And the idea of this component is that it analyzes how a particular service is evolving over time as different versions are rolled forward, and it tries to uncover trends that developers might not be aware of. Now let's quickly go over the types of experiment or continuous experimentation that iterate enables. The simplest case is performance tests. In this case, there is only one version involved. The idea is to assess the behavior of that version against success criteria that the user decides to use. In this particular example, for instance, I'm saying that this service, in order to pass the performance test, it needs to have a mean latency below 120 milliseconds and an error rate of at most 0.0001, which means like 4 nines of availability. Right? Typically, this is done in a test or dev environment, but it can also be done in production too. Canary release, of course, is another type of experiment. In this case, there are two versions involved: the baseline, or the current version, and the candidate, the version that's being assessed. The idea here is to check if the canary is meeting performance criteria or error criteria. And in this particular case, relative criteria might be important. For instance, I might want to make a determination of the acceptable behavior of a canary with respect to the baseline. So for instance, I'm showing here an example that I would tolerate for the canary an error rate that is 1.05 that of the baseline, meaning I am tolerate a 5% degradation in the error rate, if you will. And of course, in canary releases, there is a traffic control strategy that gets applied so that the traffic hopefully will gradually shift to the canary if things are going well. And if the canary fails, of course, a rollback decision is made. Yet another experiment type is A/B or ABN testing. In this case, there are 2 or more versions being compared. There's a baseline version and 1 or more candidates. And the idea here typically is to maximize some type of reward metric that is usually associated with the business. And at the same time, do so in a way that service level objectives that you want to promise to your users are still being satisfied. Right. So, and a reward metric is declared as such in the experiment specification. And what iterate does is it will optimize for that metric. In this particular case, I'm highlighting a metric that is named mean books purchased. And imagine if you are a bookstore and you want to maximize each version that you're comparing, you expect that the winning one will maximize the number of books that gets purchased during the experiment. And again, a traffic control strategy is applied, and the idea is that iterate will gradually shift the traffic towards the winner version. Now, I'm going to show you now a demo of an automated ABN testing using iterate. In this demo, we are going to see 3 competing versions. The application is a sample application that is modeled after a bookstore. And we are going to maximize business-oriented metrics, similar to the one that I just showed you in the previous slide, kind of a mean number of books purchased, while satisfying performance criteria and error criteria. So let's take a look at this demo now. I will show you how to use iterate to perform an automated ABN test. You can see iterate analytics and iterate controller running in my iterate namespace, and my sample application pod is running in my current namespace. And right now, there are no ongoing iterate experiments in that namespace. We will demonstrate experimenting with 3 different versions of a service named product page. Currently, only version 1 is running. When version 1 runs, you see a red string that I am highlighting on the web page right now. Version 2 changes that color to yellow, and version 3 changes that color to green. Now let's check the service metrics. You see request rate on the upper left, mean request latency on the upper right. You see also a metric related to revenue that is supposed to capture the number of books purchased as people browse our sample bookstore website. Now let's define an ABN test experiment for the product page service. In this definition, we specify that version 1 of product page is our baseline version, and versions 2 and 3 are our candidate versions. Our criteria for this experiment is defined as follows. In order for the candidate versions to be acceptable, their mean latency must be below 1.6 times that of the latency of the baseline version. All versions to be acceptable need to have an error rate below 5%. 95% of their requests must be below 500 milliseconds, and the winning version is supposed to maximize the reward metric mean number of books purchased while satisfying the requirements on latency and error. For the purpose of this demo, this ABN test will run for 20 iterations of 20 seconds each. We are now running kubectl apply to create an experiment from the YAML file that you saw earlier. And then we're going to list the experiments in this namespace, and you see that that experiment was created, but it's in pause state because the candidates are missing. This is expected because versions 2 and 3 of product page are not running yet. Next, let's deploy versions 2 and 3 of product page so that the experiment can automatically start. Once iterate detects that the candidates are available and running, it will automatically start the experiment. These deployments are typically done through a CI/CD pipeline, but for the purpose of this demo, we will do it manually. We have now deployed versions 2 and 3 of product page, and you see that the experiment is actually progressing. You see the traffic split at the bottom, 80, 10, 10, and the current best version is product page version 2 with 33% of confidence. That's what iterate is currently telling us. Now we have a 60, 20, 20 traffic split. Version 2 is still the best version. Every time iterate makes a version assessment and a traffic update, it generates a Kubernetes event, as you can see. Iterate has just reported that the best version is no longer version 2, but rather version 3, with a confidence of 76%. Let's quickly take a look at the metrics. You see that the mean latency of product page version 2, the yellow line, is higher than that of both versions 1 and 3. Refreshing the bookstore's website a few times, you see the color switching from red to green, and a little bit to yellow, reflecting how the traffic is being split right now. Mostly to V1 and V3, and not so much to V2, which is the yellow. Iterate has now a confidence of 89% that version 3 is the best version. And you can see the traffic gradually shifting from versions 1 and 2 to version 3. Now the confidence is 99%, and iterate is pretty much ready to declare a winner. So if you look at the metrics, you see that version 2 is violating our mean latency criterion. You see that there's a whole bunch of requests that are above 500 milliseconds, as indicated by the latency percentiles. And even though version 2 has the highest reward, it's violating the criterion on latency. And version 3 in turn satisfies the criterion on latency and has a reward higher than V1. Hence, it is the best version. Right now the confidence is 100%, and the vast majority of the traffic, 96%, 97% now, is going to version 3. The experiment continues with almost no traffic to versions 1 and 2. That's because we specified that the duration of the experiment is 20 iterations. We didn't specify an early termination in this case. Now you see again the metrics. You see reward for V3 higher than reward for V1. And you see that V2 has the highest reward, but it violates the criterion on latency. If we fast forward the video, you see that iteration 20, the experiment is completed and all traffic is going to the winner version. That's the version that shows the green color on the web page. No more reds or yellows. Now, let's do another demo. So this time, we're going to show what we refer to as human-in-the-loop experimentation. In particular, in this demo, human-in-the-loop ABN testing. The scenario in this demo is the same as before. Here's the difference. In human-in-the-loop, the user is in control of the experiment. Instead of the iterate controller automatically applying the recommended traffic split by using the assessments coming from iterate analytics, in this type of experimentation, that decision is entirely up to the user. The user sees the insights, sees the assessments, and decides what to do with them. So that's the idea. In order to support human-in-the-loop experimentation, we have integrated iterate with CUI. CUI is a visual terminal that essentially is a hybrid between a command line interface and a web interface, as you're going to see. So again, same scenario as before, 3 competing versions in ABN testing. This time around, as you will see, the user is in control. Let's take a look at this demo now. In this demo, I will show you how to perform an iterate ABN test experiment using the CUI visual terminal. As in the previous demo, the target service of our ABN test is product page. You see that we have versions 1, 2, and 3 running, but only product page version 1 is exposed to traffic. Next, we run the iterate create experiment command that will allow us to specify an ABN test experiment using a form in the CUI visualization sidecar. I am specifying the target service, the baseline version, the candidate versions, and now I'm going to add the success criteria. First criterion on mean latency, it's a relative criteria. I want the candidate versions to have a latency of at most 1.6 times that of the baseline. I want 95% of all requests to be under 500 milliseconds. I want the error rate of all versions to be below 5%. And I want to maximize the reward metric, mean books purchased, just like we did before. Now we create the experiment, and once we do that, we can go to the decision tab that will show us what kinds of insights iterate is giving us. You can see that only the baseline version is getting traffic. Each version has the same probability of winning, and iterate has not enough data to declare a winner. And it's giving now a traffic recommendation of 50, 25, and 25. Let's apply that traffic split so that the other versions can get some traffic. Now you see that the current traffic is split 50% to version 1, 25 to versions 2 and 3. Let's confirm that by refreshing the web page a few times. You saw the color switching there. Let's get more assessments from Iterate Analytics. It reports that it has not enough data to declare a winner, and it's giving us a different traffic split recommendation. Let's get yet another assessment. It's still not enough data to declare a winner. You see that version 3, however, has an 86% chance of being the winner. And let's apply the recommended traffic split of 58 to version 3, 34 to version 1, and 8 to version 2. Let's get another assessment. It's still not enough data to declare a winner, but the confidence increased to 97% to version 3, as you can see. Let's take a look at the metrics to understand what's happening. You see the latency of version 2 is higher than that of versions 1 and 3, and it's actually violating the criterion latency because quite a few requests from served by version 2 are not below 500 milliseconds. And you see that it has the highest reward. Version 2 has the highest reward, but it is violating the criterion on latency. Therefore, it has a very, very small chance of winning. Version 3, in turn, has a higher reward than version 1 and satisfies the criterion on latency. If we get another assessment now, you see that we can finally declare that version 3 is the winner with 99.8% confidence. And the current traffic recommendation is 96% to version 3 and only 2% to versions 2 and 1. At this point, basically version 3 is the winner with high confidence. And we just applied that traffic split. And you see the same trends on the metrics. And at this point, let's take a look at the advanced statistics. Now we are showing you the credible interval statistic for each metric of each version. That is the interval within which the true value of each metric lies. The more data we have, the closer the two ends of the interval become. Let's end the experiment now and let's choose to roll forward to the winner. After doing that, we will basically shift 100% of the traffic to the winning version, which is, in this case, product page version 3. That is the version that shows the green color on the web page, which we can confirm by refreshing it a few times. Finally, I will show you the iterate metrics command on the GUI visual terminal. This command can be used to both define metrics and visualize metrics. You are seeing each of the metrics that we used in our ABN test experiment. Note that mean latency, error rate, and error count are default metrics that come out of the box with iterate. The others are custom metrics we created for this experiment. All right, let's summarize what we have discussed. So we showed you iterate. So we raised awareness for a key problem in continuous experimentation. And the goal of iterate is really to unleash the power of continuous experimentation in Kubernetes. And it does that through statistically robust techniques driven by machine learning for version assessment and traffic control. This is a state-of-the-art techniques, and we happen to have some scientific work that we've done to substantiate that. Iterate currently supports, Kubernetes, Istio for control, and it uses Prometheus for metrics. And in addition to the integration with QUI that I showed you in the previous demo, Iterate is also integrated with Kiali. Kiali is the de facto open source UI for the Istio service mesh. So we have an Iterate extension for Kiali that can be used to create experiments right there and observe the experiments as they run. Here's where to find us. You have a link to our Iterate's landing page and our GitHub organization. Thank you so much for your time.
Hello, everybody. I think you can hear me live now. So there's a little bit of a glitch in the pre-recorded video. So I hope you were able to follow everything. I'm happy to entertain any further questions that you might have. And we can also continue the conversation over Slack in the KubeCon 2-KubeCon-CICD Slack channel. So I'll wait to see if there are more questions. Let's see. There's one question here that I see. So let's see. Second, okay. I can see some questions here that I haven't answered yet. So let me try to answer. There are 4 questions or 6 questions that I haven't answered yet. So let me try to address them now live. Does this follow SMI's traffic split definitions of Canary B, etc.? So we have our own CRD that we define that we call of the kind experiment. And we use Istio's control plane to control the traffic across multiple versions. So again, we define our CRD, and then we rely on Istio for control. So let's see the other question. Can Iterate deal with removing the unsuccessful candidates deployment from Kubernetes? So yes, there is one option in our CRD that allow you to basically clean up after the experiment is done, in which case it would remove the versions to which traffic is no longer sent after the experiment. Another question is, it's possible to have a session user stickiness in the experiment. So this is sort of orthogonal to how Iterate performs an experiment. Although for kind of the AB type of experiments, ABN type of experiments, you can kind of limit the universe of users to which the traffic is going to be kind of that they will participate in the experiment. But session stickiness is kind of orthogonal to the operations of Iterate. Let's see, there are more questions. Are the statistics also available using kubecontrol and similar tools? So there are some statistics that are associated with the custom resource that the user creates for the experiment. So if you kind of look at all the details of the CR, you should see some information there. And during the experiment, of course, there are richer information there. And we kind of emit every time there's a decision made. There's a new version assessment with the new confidence. We emit a Kubernetes event doing that, so we can also see it through that. Anyone is using it for production. We have some proof of concept engagements with some users, and we're getting there. What kinds of trends can trends module detect? So right now we can basically we rely on the metrics that comes out of the box with iterate plus utilization metrics. You can see if there are spikes, anomalies in those metrics right now. So if you see something is deviating from the normal, and we did some as part of the iterate umbrella project umbrella, we did some work on kind of time series analysis. We didn't bring those into the trends module yet. So the trends module is pretty new. We're still actively developing it. How many experiments is possible to run at the same time? The limit is it depends on it. There's no limitation in iterate per se, limiting the number of experiments that can happen at the same time. It boils down to your Kubernetes cluster in terms of resources, etc. So I think we are running out of time. I will be engaging with you folks in the 2-kubecon-CI/CD Slack channel to answer further questions and engage with you further. Thanks for watching. Thanks for engaging.